the limitations of that study, and finally what we think is the potential usage of that mapping. Okay, so first of all, we are working with xvid, that is a vocabulary that was developed by Google, Yahoo, and Bing during 2011, and it provides some vocabulary, so webmasters could mark up their web pages using microdata. Microdata has some tags, so you could know which is the type and properties of a value in a web. For example, if you have the string of IBM, you can know that it is the name of the company. Microdata allows search engines and other applications to have the content of web pages more readable, and that benefit users so they can have better results when they do searches and when they want to find relevant information on the web. The other side of our study is the link open data, because it's another way to do information for consumption for machines. And open data is a project that has open data sets published in RDF, and they are linked also with RDF. So you can discover new data and you can share data between the other data sets. So our point here was that we have two things that provide information to the web. One is xvid, and the other is link open data. So we were interested in about mapping both. The thing is that if we have information from linked open data, we can retrieve it to web pages tagged with xvid. So the first step in that is that we need to do a mapping between classes and properties from xvid to classes and properties of some vocabularies of linked open data. But the problem is that we also need some metrics about that vocabularies and that data sets. So that's why we have decided to use linked open vocabularies. That's a project that has some vocabularies from several fields, and its objective is to provide access to that vocabularies, how they are interlinked, and how they link with the linked data cloud. So having our mapping, we can retrieve information, and we have some statistics that are provided by law. So which materials and tools have we used? First of all, we have downloaded 238 files from the web page. We couldn't download all because some of them are well formatted, or they have the permissions to access them are not provided. Then we have do our matching using a script that has been developed with a library in Ruby called RDA.rb. And we have matched classes with classes and properties with properties. And finally, we have used LogStats, which is a project that provides statistics from RDF datasets, so we can have some metrics about our mappings. And examples of how we have done the mappings is there. So you can see, first of all, the first part of the script is to match classes with classes, as you can see there, first. And then when we have a matching between classes, we are matching the properties of this class. As you can see here, person has property, family name, and then we are matching it with the vocabulary. Okay, here is a first view of our analysis. So we have decided to compare it with another matching tool, which is called logmap. And here in that table you can see the comparison between the top occurrences of classes that we have obtained, and we have compared it with logmap. A stands for our scripts, and B stands for logmap. As you can see, there are some differences. I'm explaining why we have that. Okay, for example, the first 3 points, it's some things that logmap are better than our script because, for example, it discriminates special characters. So you can find a class like government organization separated, but also logmap will match that class with government organization without using special characters. Another thing is that it distinguishes between the different types of English. So organization is sometimes it's written with S and sometimes it's written with Z. So logmap can match it well. And the other thing that logmap is better is that it uses synonyms. So school is not with college. But that could have a problem that we have found that